In the heat of the summer solstice, the crimson sweet watermelons reach peak maturity. Nature's giant berry sits heavy on the vine, filled with 92% water.
The thump test is ancient. A hollow, deep resonance signals a crisp, sugary interior.
We check the belly. A creamy yellow spot means ripe. White means it needs more time.
Once detached, the clock starts. The vine no longer pumps water to the fruit.
The stacker is the most skilled job. A dropped melon is a lost melon. They are stacked tight like bricks. Any gap could cause the load to shift and crush the bottom layer.
Carrying 40,000 pounds of fruit, the bus heads to the transfer hub. For the factory, we consolidate the loose fruit into standard macro bins. Each bin weighs 700 kilograms. Mechanical muscle takes over.
The flatbed can carry 48 bins. That's nearly 30 tons of watermelon.
The load must be secure. Shifts in weight can tip the trailer on highway turns. From the soil to the highway. The journey to the processing plant takes 4 hours. We arrive at the cold facility, designed specifically to handle large melons. The first priority is getting the load out of the direct sunlight.
Visual inspection confirms the load survived the journey intact.
Precision starts at the gate. We must determine exactly how many tons of watermelon have arrived. The growers are paid by weight, so accuracy here is financially critical. We measure the pulp temperature. Field heat must be removed quickly to stop the ripening process. A Brix measurement of 11 or higher is required for premium processing grade. The offloading begins. Speed is balanced with gentle handling. Each bin holds nearly half a ton of fruit. Dropping one would be a disaster.
Traceability is mandatory. We track every melon back to the specific patch of soil it grew in.
They enter the pre-cooling chamber to bring the pulp temperature down safely.
Forced air pulls the field heat out of the center of the melons over the next 6 hours.
This buffer ensures the factory line never runs out of fruit, even if harvesting stops for rain. Cooled and rested, the watermelons are ready for the extraction line. Automated tippers take over the heavy lifting, sparing workers' backs. Gravity does the work, pouring the fruit into the intake system. We dump into water to cushion the impact. Luckily, watermelons are naturally buoyant. The flume acts as a transport system and a pre-soak to loosen dried field mud. Field debris, leaves, and vines are filtered out immediately. Rising from the soak tank, they head toward the facility entrance. Leaving the receiving dock, the fruit enters the high-care sanitization zone.
Spanning 500,000 square feet, this facility is a fortress designed for food safety.
Access is strictly controlled. Only certified personnel can enter the high-care zones.
White uniforms are mandatory. Human hair is a major contaminant risk.
The hygiene sluice is an automated gatekeeper. It physically blocks entry until protocols are met. Sensors dispense a hospital-grade bactericide. A chemical bath sanitizes the soles, preventing pathogens from tracking in. Jets of filtered air at 25 meters per second strip away any remaining dust. He enters the high care zone. The air here is filtered to surgical standards.
From the catwalk, we can see the wet line receiving the fruit we just unloaded.
Our harvest has arrived. Now, the transformation begins.
The flume is a gentle transport system, using water to move the heavy fruit without bruising.
Pleated belts are necessary to lift the 20-pound fruits out of the soak tank. Continuous rotation ensures every inch of the rind is exposed to the cleaning jets. Jets at 100 psi strip away stubborn field clay and dried soil. Firm bristles polish the rind, removing any bacterial films attached to the surface. Rinsed and sanitized, the true condition of the fruit is revealed. The skin must be bone dry for the optical cameras to scan it accurately. Visual inspection is the only way to catch subtle defects like sunburn or soft spots. Cracked fruit ferments quickly and is removed immediately to protect the batch.
Nothing is wasted. Rejects are diverted to local livestock farms.
Must be separated. No two melons can touch. Optical graders take 60 images of every single watermelon in a split second. The algorithm calculates the optimal cutting pattern for each individual fruit. Air-actuated arms divert the fruit into designated size lanes. Size matters. The cutting machines must be calibrated to the specific diameter of the fruit.
A final surface sanitation ensures that when the knife enters, no bacteria travels with it. They now enter the high care cutting zone, kept at a constant 4 degrees Celsius.
The fruit is centered vertically. Even a slight wobble would result in uneven peeling.
Sensors track the oval contour, removing the rind with millimeter precision while saving the flesh.
Simultaneous trimming squares off the ends, preparing the fruit for the slicer. Stripped of its armor, the delicate red flesh is now exposed and vulnerable.
Human eyes spot the remaining white pith. Ideally, only pure red heart remains.
Splitting the cylinder stabilizes the fruit before it enters the dicing grid. The internal structure is revealed, crisp, sugary, and ready for cubing.
A final ozone shower kills surface bacteria instantly, without using harsh chemicals.
In a fraction of a second, the large melon is transformed into uniform bite-sized cubes.
Cutting releases juice. The shaker table separates the liquid so the package isn't soggy.
Small fragments and mush are filtered out. Only firm cubes make the grade. Optical eyes scan for color. Anything white or green is identified as a defect. Compressed air ejects the rind with sniper-like precision.
The product is now 100% pure hard meat, visually perfect.
The excess juice is captured for beverage blends. Nothing goes down the drain. The green rinds are sent to local dairy farms. Cows love watermelon. The cubes are now in their most perishable state. They must be packaged immediately. To preserve the structure of a fruit that is 92% water, we must freeze it instantly. Gravity takes over now, feeding the high-speed weighing systems. The fluidized bed technique suspends the fruit in a -40-degree polar wind.
Flash freezing prevents large ice crystals from forming, which would rupture the cells and turn the melon to mush.
After 8 minutes, the core temperature reaches -18 degrees Celsius. They emerge transformed, from delicate, watery fruit to durable, frozen solids.
The texture is checked. If it's soft, the freezing failed.
Clumps are broken up, but the freezing process shakes loose some small fragments. Watermelon is fragile. Broken pieces are diverted to the juice extraction line. The hammer mill obliterates the fiber, turning the fragments into a smooth, puree base. Passed through a micron filter, the byproduct becomes a premium clear juice.
Flash pasteurization sterilizes the juice without cooking off the delicate melon flavor.
While the cubes go to retail, the juice is packed in drums for beverage manufacturers.
Before weighing, the fruit must be spread thin to ensure accurate counts. One final check remains before they are sealed in plastic. They enter the optical sorter, which will remove any cube that doesn't meet the color standard. Lasers scan the fruit thousands of times per second, detecting defects based on color and water content. Pneumatic ejectors fire with sniper-like precision, removing imperfections without touching the good fruit. The rejection threshold is strict. Only pure red heart meat makes it to the bag. Only the flawless cubes survive the optical gauntlet, moving up to the weighing deck. Vibration feeds the fruit evenly into 14 separate holding chambers. The machine doesn't weigh one big pile. It weighs 14 small piles simultaneously. The computer finds the combination of buckets that adds up to exactly 500 grams.
This eliminates overpacking. The accuracy is within 1/10 of a gram.
Packaging film travels at 2 meters per second to keep up with the falling fruit. The forming shoulder transforms the flat sheet into a continuous cylinder. A vertical heat seal creates the spine of the bag. Batch codes and expiry dates are stamped instantly on every unit. Nitrogen gas displaces the oxygen, preventing freezer burn during storage. The bag catches the falling charge of fruit perfectly. Though the filler is accurate, the check weigher is the final judge. It verifies the weight of every single bag of watermelons. Underweight bags are instantly rejected. Regulatory compliance is non-negotiable.
It can detect contaminants as small as 0.8 millimeters.
Parallel to the fruit line, the case erector builds the shipping cartons. 8 bags per case. This modular packing maximizes space in shipping containers. Vibration ensures no bag gets pinched when the top flaps close. The cycle is complete. The fragile fruit is now fully armored in corrugated cardboard. Smart labels track the product's origin, shift time, and destination market. Gravity assists the logistics, bringing the finished cases down to the palletizing hall. Automation handles the heavy lifting. A fresh pallet is staged every 3 minutes. The palletizer works tirelessly, stacking cases in an interlocking pattern for stability. A full pallet weighs nearly a ton. Manual stacking at this speed would be impossible. Slip sheets are added to increase friction, preventing the column of boxes from toppling.
While the pallets stack up, the science team validates the safety of the lot.
Rapid thaw protocols prepare the fruit tissue for microbial analysis.
First, the taste. The Brix test measures sugar content. The watermelon must be above 11%.
Sweetness confirmed. Now we hunt for invisible enemies.
Samples are cultured to detect E. coli, salmonella, or listeria hiding in the fruit. Results take 24 hours. The watermelons cannot leave the warehouse until the all clear is given.
The texture analyzer measures firmness. Freezing shouldn't turn the watermelon to mush. Colorimeters ensure the red hue meets the specific standard required by retailers. A retention sample from every watermelon batch is kept for 2 years in case of future customer inquiries.
They don't just test the fruit. They test the water the watermelons swim in every hour.
Every hour, the metal detectors are challenged with test pieces to prove they are working.
If a detector fails the test, every bag of watermelon processed since the last check is quarantined.
Integrated pest management ensures insects are monitored and kept out of the production zone.
Environmental swabbing hunts for harborage points where bacteria might hide in the machinery.
Machines measure sugar, but only humans can judge the nuance of flavor and crunch.
The data converges. Watermelon batch #4092 is officially cleared for dispatch.
This piece of paper is the passport the fruit needs to cross international borders. The finished watermelon pallets enter the cold store. Capacity, 4,000 tons. Precision drivers slot the inventory into high-density racks with only inches of clearance. Here, the product enters a dormant state, awaiting orders from the global market. When a purchase order arrives, the first-in, first-out system identifies the oldest batch.
The shipment is staged on the loading dock, double-checked against the shipping manifest.
The reefer container arrives pre-cooled. Before a single box is loaded, the vessel is inspected for odors, debris, and temperature integrity. Loading is a game of Tetris. Pallets are placed tight against the bulkhead to maximize airflow.
This logger records the temperature every hour for the next 4 weeks.
Once the bolt seal is snapped, the cargo is legally in the hands of the shipping line.
But for the consumer, the taste is as fresh as the moment it was picked.
And this is how modern factories produce frozen watermelon from start to finish.